12th standard physics. So in this class we are going to discuss about force between two long parallel current carrying conductors. So consider the conductors A and B are parallel to each other, separated by a distance R. So current I1 is flowing through the conductor A, then I2 is flowing through the conductor B. So due to the current I1, so what is the magnetic field at this point? So at the conductor B, so that they are separated by a distance R. So what is the magnetic field at this point? So current carrying conductor, so current is flowing through the conductor, there is a magnetic field that is perpendicular to the conductor. So magnetic field B1 is equal to, so the magnetic field at a distance R distance. So at this point, so the magnetic field is into the page. So that is, see the directions X, Y and Z. So this one, so Z is upward direction, then X. So in this is into the page, so it's minus X, so minus I cap. So B1 equal to mu 0 I1 by 2 pi R minus I cap. Then what is the Lorentz force on DL of conductor B? So conductor B, so current is flowing. So consider this one. So conductor B, current is flowing. So there is a magnetic field. So the magnetic field, just think like that. So like that. So current is flowing, that is I2. So this one is magnetic field. So current flows, then magnetic field perpendicular to each other means there is a magnetic force perpendicular to each other, like that. So that Lorentz force is equal to I2 dl cross B1. So that is magnetic Lorentz force is due to the magnetic field produced by the conductor A, that is B1. So df equal to, that is small current element dl. So I2 dl cross B1. So current I2 is flowing. So magnetic field is perpendicular, that is into the page. So what is the magnetic Lorentz force? So A cross B. Then you need to substitute the value, just that B1. So mu 0 I1 by 2 pi R. So mu 0 I1 by 2 pi R. Then here the current direction. So what is the direction of current in upward? That is Z. So it's K cap. So K, then minus taken out. So K cross I. So I J K. So if it is I cross J is K. K cross I is J. So like that it's a clockwise. If it is anti-clockwise, K cross I is minus I. That's all. So K cross I. So it's minus. So K cross I, it's clockwise. So K cross I is J. So J is minus. So what is the direction of force? So F by L. So here it's small force. So that is DL is a small element. So just get it into denominator. So we need to have a total force, that is total Lorentz force is, it's F by L. So F by L equal to minus mu 0 I1 I2 by 2 pi R J cap in negative direction. So negative direction means, so that force F, this is positive y axis, so negative y axis the magnetic Lorentz force acts. Similarly, so you need to find, so what is the magnetic field due to the conductor B at the point that is R distance. So again the same procedure. Here the magnetic field is here into the page, is coming out of the page. So it's positive, it's coming out of the page. So X, so positive I cap. Then what is the magnetic field? What is the magnetic field? B2. B2 due to that magnetic Lorentz force. So df equal to I1 dl B2. It's same case, it repeats, but the direction is changes. So it's into the page, then coming out of the page, that is plus I. So K cross I is equal to J. You will get positive. So F by L here positive, here negative. This is the difference, plus and minus. So the direction of force. So one force in this direction, another force in opposite direction, like that. So in this, like that means, for example, so force acts in this direction, another force acts in this direction. This is plus x axis, this minus x axis. Similar, plus y axis and minus y axis, because it's j cap, minus j cap here, plus j cap. That's all. So F by L is equal to plus, here minus. Then, so the current carrying conductor are parallel to each other. If it is the two conductors, the current direction is in same. So I1 I2 flows in the same direction means there is a force. So there is a force of attraction. So the current flows in the same direction means there is a force of attraction. If it is in opposite direction, so current I1 goes upward, current I2 goes downward. So there is a repulsive force between them. Then finally ampere. So ampere is a unit of current. So define 1 ampere. So what is 1 ampere means? Just consider. So two parallel conductors. So two conductors, the current flowing is 1 ampere. Just consider. So if it is I1 equal to I2 equal to 1 ampere, then the distance between the two conductors is R, that is 1 meter. So we know the value mu 0 equal to 4 pi into 10 power minus 7. So just substitute the values. So 4 pi into 10 power minus 1, then 1 ampere into 1 ampere, again 2 pi R. So 2 pi will get 2 into 10 power minus 7. So what is the unit of force? Newton. Then unit of length meter. So if a current carrying conductors, two conductors, parallel conductors, if it is 1 ampere current flows means there is a force of attraction or repulsion. It depends upon the direction of flow of the currents. That force is 2 into 10 power minus 7 Newton per meter. That's all. That's a definition of ampere. So in this class we have discussed. So first it's a 5-mark question. So force between two long parallel current carrying conductors. So two long current carrying conductors. So what is the force? If it is a repulsive force or attractive force. Then so what is the thing is followed? So first consider a current carrying conductor A. So what is the magnetic field at the point B due to the current I1? So it's R distance. Then we find the what is the magnetic field. Then this magnetic field experiences a magnetic Lorentz force because the current is flowing. So there is a magnetic field inside. So magnetic field, the charge is moving with velocity V. So the magnetic field and charge perpendicular to each other, there is a magnetic Lorentz force. So what is the magnetic Lorentz force? We are finding using the right hand, that is F equal to BAL sin theta. So here angle is 90 degrees. So it's I2 DL cross B1. It's similar case again. We consider I2. So current is flowing in the conductor B. What is the magnetic field at the point B2? So it's R distance away. Then from this magnetic field, so there is a magnetic Lorentz force produced. So this magnetic field is, it's coming out. Coming out means like that. Coming out. So coming out means, so just this is coming out. Then coming in means, so the pen goes inside the board. So what is the direction of magnetic field? So you will get the magnetic Lorentz force. If two current carrying conductors parallel, the direction of current is in same direction means there is a attractive force between the two conductors. So the current direction, so one goes upwards, another goes downward means in opposite direction, there should be a repulsive force. Then what is the definition of ampere? So ampere means, so two current carrying conductor flows 1 ampere means there should be a force of attraction or repulsion is 2 into 10 power minus 7 Newton meter power minus 1. So okay students,